Hey everybody, it's Mr. Portasio here, and in this video, I'm gonna help you create scatter plots and make predictions using lines of best fit. So, as you did your exploration phase, you were able to figure out how to plot coordinates and also how to create line of best fit. Now what we're going to do in this video is we're going to use sets of data to make future predictions. So in this example, we're only going to do question number 1. Okay, so we're just going to do question number 1. Okay, so I'm going to highlight that for you guys. So right now the screen looks a little bit weird, right? There's two screens. There's a split screen on the left and one on the right. The split screen on the left shows the question, and the split screen on the right is an application called Desmos. So I'm also going to show you how to use Desmos, but you can find the link in your Google slide. Okay. All right, so first, let's go ahead and just read this question. Let me highlight it for you guys, and I'll read it afterwards. Okay, so the table below gives the numbers of hours spent studying for a science exam and the final exam grade. So here we have sets of data. The first row is the number of hours studying. The second row, right, so this is the first row. Let me just draw an arrow here. This is the first row. That's the hours of studying. And the second row, I'm drawing an arrow now. This indicates your grade. So it's very important to understand how to read data, right? So for example, if I didn't study at all, what do you think would be my grade, right? That's a very important question. So taking a look here, if I had not studied at all. So an indicator is 0 hours. I studied for 0 hours. Well, my final exam grade for science is 63%, right? Well, what about if I studied for 5 hours? Well, taking a look at the data, if I studied for 5 hours, I would have got a grade of 92% on the final exam. All right, so the first thing we're going to do is we're going to work on letter A. So letter A, we're going to use a graph paper, but instead of using an actual paper, we're going to use the program called Desmos. That's the split screen on the right. And we're going to use the data point to create a scatter plot. So what is a scatter plot? Well, a scatter plot is basically just sets of coordinates. It's a bunch of coordinates. So as you can see on the right, there's actually a bunch of coordinates already there, right? But we're actually going to erase these, and we're going to put in the coordinates or data that I'm highlighting right now, right? Which is the number of hours you studied and the corresponding grade. So one thing to decide, and it's very important, is to decide what values are going to be for your x-axis and your y-axis. So for this example, I'm going to say the number of hours I study is my x-axis, and the corresponding grade is going to be our y-axis. The reason why we do this is because we want to create that consistency. Data is not going to be accurate if we're switching values around. So let's go ahead and plot some scatter points using this data. So we're going to use the first set. I'm going to circle it now. Okay, the number of hours you studied is 2, and the corresponding grade is 77%. So what I'm going to do on the right split screen is I'm going to look at the first column, which says x1, which basically means our x value, and y1, which is our y value. So if you wanted to, you can actually take a look at this set of data and make it into coordinates. So if the hours we studied is 2 hours, well, the corresponding grade is 77%. We can go ahead and rewrite this using our table on the right side of the split screen. So our x value is, well, we studied for 2 hours, and the y value is our final grade, 77%, right? So notice on this graph is, well, where is this particular point, right? So one thing we can do is we can zoom out. So one way to zoom out is if you see the minus sign, you're zooming out. And notice here there's a point, a coordinate point right on top, and that's actually our coordinate, 2, 77. This point stands for, well, if you study for 2 hours, you get a grade of 77%. So what I'm going to do is I'm going to continue by doing the next point, because if we want to do a scatter plot, we have to do it with all the points. Now, okay, if I studied for 5 hours, I should get a 92%. If I studied for 1 hour, I probably should get a 70%. If I studied for 0 hours, that's 63%. If I studied for 4 hours, that's 90%. Here's another student that studied for 2 hours. They got 75%. And lastly, a student that studied for 3 hours got an 84%. So notice here we have excess data. To get rid of this excess data, all we would have to do is press the arrow going back with the X on it. Okay, it will delete it. Okay, so now we have here is our set of data. So I want to make it more visible to myself. So what I'm going to do is I'm just going to zoom in. Right now I can see each and every data point. Right? I got all of these values. Right? Keep in mind all of these values pretty much derived from our data set. Okay? All right, so that's letter A. We created a scatter plot using the data. Now, we're going to move on to letter B. Okay, so now we're looking at the left side of the split screen. So, letter B, what is the equation for the line of best fit? Sketch this on your graph. So, as of right now, right, I haven't taught you anything on creating equations. But what we can do is we can actually create a line of best fit. And essentially, what a line of best fit is, it's a straight line that would hit as much coordinates on the coordinate plane as much as possible. So let me show you guys an example. So now we're going to look at the right side of our split screen. Okay, so you're going to notice an equation here, and it's color orange. It says y equals mx plus b, right? And this is something that we're going to be studying in the next couple of chapters. But what is y equals mx plus b? Well, generally speaking, it's an equation of a straight line. But the letter M and the letter B, they do something very specific. And I'm not going to go into detail with that just yet, but I'm just going to explain what they do. Okay, so I'm just going to zoom out so we can see what they do. So the letter M, it tells us our steepness, right? Notice as I'm moving the cursor to the right side, it's getting more steep. And as I'm moving it to the left, it gets less steep, right? It's kind of going downwards, right? So I'm going to create a line of best fit. So I'm going to try to find the same exact steepness as these points, right? So it looks like the steepness is kind of the same, right? So here we're just making a estimate or a good guesstimate, but we could always change this later on. Now letter B, what letter B is? It's pretty much the x-axis, or our y, this is actually our y-intercept, right? If you're familiar with the word y-intercept, that's great. And essentially what a y-intercept is, say the value 3.6, it's hitting the graph at 3.6. Okay, but I'll go further into detail with that one. Okay, so one thing that we can do here is, and you guys can actually follow along with me here, is notice there's a restriction on this scale from -10 all the way to +10. If we wanted to, if we click on it, we can change that restriction. So some values that you can use, maybe let's try -100 and +100. So what this does, it pretty much increased it pretty much increased the value. So notice it can actually go more to the right and more to the left. Okay, but if you have any questions with this, you can let me know. Okay, but again, I'll go in further detail what is M and B in a future lesson. Okay, so what I'm doing here is I'm kind of recalibrating it to the point where it's hitting more data points or scatter plots. Okay, so let me just zoom in. Right, so keep in mind, right, these are just estimates. Everybody might have different lines, but again, these are just estimates. So as I go to the left, it looks like, I would say, this is a good line of best fit. It's hitting as much points as possible. Okay, so this would be considered sketching the graph of our line of best fit. All right, so now what we're going to do is let's try something pretty important, right? Letter C, this is the gist of this whole lesson. We're going to predict an exam grade of a student who studied for 6 hours, right? So one thing that we can do is we can use the line of best fit to tell us, well, to tell us a prediction of if a student studied for 6 hours, well, what is an estimated grade? So remember, right, in a scatter plot, the x value tells us the number of hours they studied, and the y value tells us a predicted grade. So on Desmos, if you put your arrow on the line, on the orange line, it gives us values. So notice here, right? The x values are changing, the y values are changing. But one thing that we're concerned with is 6 hours. So I'm going to make our x value at 6 hours. Okay, let me see if I can get it here. Okay, I think you guys can see that here, right? At 6 hours, an estimated grade is 100.4. Okay, so I'm going to write that here. An estimated grade, if you studied for 6 hours, is 100.4%. So keep in mind, right, this is just an estimate, right? Okay, so let's take a look at letter D now, right? And this is going to be our final question here. Can this line go on forever? Why or why not? So technically speaking, right, this line can go on forever, right? It's just going to keep on going forever and ever and ever. But we're not really concerned about what's going to happen past maybe 6 hours. And the reason why I say we're not concerned about what happens past 6 hours is because the highest possible grade you can probably get is 100%. So if I studied for 6 hours, right, we already concluded that you'll get 100.4%. So if I studied for 7 hours, let's just take a look at this for example. If I studied for 7 hours, well, I should get 106%. But I don't really need to get 105 or 106% because the highest possible grade is 100%. So hopefully, I know this video was kind of long and it looks a little bit challenging, right? But I know you guys are capable of doing this one. Again, if you guys have any questions, feel free to ask me and I will help you. Okay, so this is our lesson on looking at data, creating scatter plots, and making predictions using lines of best fit.